right, so the book, I think we talked about this, but the book puts all the inverse trig in one section, and we're kind of slowing that section down. So the first part of 5.6 is what we did Friday. That was pre-cal stuff, just remembering how to do inverse sine and cosine and tangent. Today we're going to do derivatives, and tomorrow we'll do inverses. Derivatives of inverse trig functions. And then again, tomorrow will be day 3 where we go backwards. So 3 new rules to know. The sine, cosine, and tangent rule. So the derivative of inverse sine. This is going to you're just going to have to know this. You're going to add this to the list of derivatives that you know, right? We know how to, all these different cars, and we know how to derive forward, if you will. And we saw some of those in warm-ups. We're going to add a new vehicle to our lineup here. The derivative of inverse sine is 1 over square root 1 minus u squared du. It's one of the more complicated ones, but you just got to know it. I'm going to give you all 3. I'll box them up, and then we'll do some examples with them. The good news is sine and cosine have a lot of things in common, right? Like the graphs look alike, they have a lot of properties the same. Their derivatives are really related to each other because you go back and forth, except for the sine thing. Well, the good news is derivative of inverse cosine is the same thing as inverse sine, except there's a minus sign on it. So those definitely go together. And sneak preview for tomorrow, the good news is if you're going backwards, you don't ever have to go backwards into inverse cosine because you could just take the negative out front and make it inverse sine. So it's really easy driving backwards from these. You don't have to worry about inverse cosine because everything will be inverse sine. All right, last one. Well, tangent has always been kind of the oddball, right, of the trig functions because the graph looks different, the period's different. It's y over x rather than just, y or x. So there's lots of things different about tangent. Its derivative is going to look different. And this is like the only place that tangent is better than the other two. Tangent's usually more complicated. But derivative of inverse tangent, 1 over 1 plus u squared du. Again, you just got to add that to the list of things you got to know, derivatives that you know. Let's do some. The DUs, by the way, those are the chain rule things. So the first part is the rule, and then the second part is the chain rule, tagging on to the end of it. Let's find some derivatives then. Practice here. So let's say y equals inverse sine of 4x. So y prime. So right now this is our first day, first problem. We don't have this memorized. We're just looking up at the rule. And the rule is 1 over square root of 1 minus the argument squared. So 1 over square root 1 minus 4x squared. But then chain rule, don't forget the 4. Perfectly acceptable safe stop answer right there. But if we wanted to clean it up a little bit, we'd probably square the 4x, make it look a little nicer. Number 2, f of x equals arctan of x cubed. Remember, arctan is the same as inverse tangent. In fact, some people that really don't like arctan, they'll rewrite it every time as the inverse. That's not necessary, but if it helps you, then do it. So the derivative for inverse tangent. Again, not familiar with them yet, so we're just looking up at the table. 1 over 1 plus argument squared. So 1 over 1 plus x cubed squared. And then chain rule, derivative of x cubed is 3x squared. Perfectly acceptable safe stop. Back of the book, Calc Chat, AP tests, multiple choice is going to clean it up a little bit. Make that, let's see, power to a power, we multiply. So 3x squared over 1 plus x to the 6th. Number 3, haven't done a cosine yet, so you can guess correctly that this is going to be a cosine problem. In fact, let's make it a little extra tricky. Arc cosine of x over 2, and then all of that cubed. So what's the first rule we're going to apply? The power rule. So 3 times whatever that is squared, and then we'll start the chain rule thing. So 3 times all that squared. All right, that's how I'm thinking about it. I need to fill in the blanks here, but that's the power rule. 3 times arc cosine of x over 2 squared. Chain rule of arc cosine, -1 over square root of 1 minus argument squared. Argument was x over 2. And then another chain, so this is why we did warm up number 3, this double chain thing. The derivative of x over 2 would be 1/2. Got lots of chaining going on here. And that would be a safe stop. But as you figured out, sometimes we work problems just to make sure our algebra is okay. So I'm going to rearrange a bunch of this stuff and then clean it up a little bit. So I know it's -3 arc cosine of x over 2 squared, and in the bottom 2 square root 1 minus x squared over 4. Calc Chat wouldn't be done with that, because we got a fraction and a fraction. We'd like to fix this. So it'd be nice if we could multiply something into that to make that 4 go away. And in fact, this one's kind of set up to work for us already, because I could rewrite that that 2. I'm just going to rewrite it as a square root of 4. This one's kind of rigged. So now they're both square roots, so I can multiply them together. I can distribute that 4 into the square root. And I can only do that because they're both square roots. So square root of 4 minus x squared. So there's your multiple choice calc chat answer. So again, if you have the option of safe stop, by all means safe stop, don't mess up the algebra. But on a multiple choice test, you have to be able to see how to get from your initial answer to a condensed, simplified answer. Let's do one more. Again, this one's more about the algebra than the calculus. Well, I say that. There's definitely some calculus going on here. Y equals x times inverse sine of x plus, just going to make this one all kinds of wacky, square root of 1 minus x squared. So I got 2 pieces here. What rule am I going to have to use on this first piece? Product rule. So combining, again, we're always combining the things that we already know with the new stuff. So this is at least that part is a product rule. And in fact, this part, I'm going to rewrite that as a power of 1/2. Because I don't really take derivatives of square roots. I take the derivatives of powers. Okay, so product rule. So that's one of them times the derivative of the other one, plus vice versa. So I don't guess it really matters what order we do it in, since it's adding. So we'll go x times the derivative of inverse sine. Let's see if you remember the derivative of inverse sine without looking at it. 1 over the square root of 1 minus x squared. Chain rule, but the derivative of x is 1, so we're good on that part. Plus, so I'm still working on the product rule here. The other way would be the derivative of x, which is 1, times inverse sine. All of that is the product rule. Then we can't forget this last part over here. Plus 1/2, 1 minus x squared to the negative 1/2. Chain rule times negative 2x. And again, left on your own, safe stop, be done. Like the rest of that is algebra cleanup. And we don't do that if we're given the choice. Let somebody else clean that up. But on a multiple choice test, let's see if we can just clean this up and see if anything happens here. In this last part, so it becomes negative, the 2's cancel, and I'm going to put that 1 minus x squared to the negative 1/2, that would be a square root in the bottom, right? The 1/2 is a square root, the negative flips it over. Are you shaking your head because you don't like it, or because you don't understand it?
What are the odds of that? It just played out perfectly.
It did play out perfectly. It's like this problem was rigged from the get-go because these two things now cancel each other out. Guys, that was a rigged problem to make that work. Somebody had to really think about things to get that as an answer. All right, assignments page 372, 39 to 53 odd. Again, section 5.6 if you're checking in Calc Chat. So 3 new rules, or like 2.5 new rules, I guess, because sine and cosine are so similar. And again, this is just practice driving forward, but you got to practice because tomorrow we're going to take this new vehicle and go backwards. So you got to drive it forward before we can drive it backwards.